everyone. Hello everyone. So now this chapter is all about schedule. So what we're going to talk about here is project schedule management. So as I have explained you before how the chapters are and how we're going to go ahead. So schedule management is all about define activities, sequence activities, estimate activity, durations, develop schedule, and then control schedule. Let's talk about this more. Let me tell you, it's estimate activity durations. Okay, so let's talk more about it. There you go. So I'm going to explain you now in more simple terms what it is exactly, what you can expect from here. So we're going to talk about the plan schedule management plan. We're going to talk about define activities. We will define activities. Let me explain. And then we're going to sequence those activities. We're going to estimate those activities, and we're going to develop the schedule and control it. What it means. So it means we're gonna define the activities. It means I'm gonna write the activities. Suppose I'm writing one activity for the designer, design the page 1, and then I'm writing another activity, just suppose development for page 1 part A, and then development of page 1 part 2, or development of page 1 part C. So there could be like many different parts of one page. Maybe I'm just dividing that into the activities. So basically it's what I have said in a scope. We basically have a big work, a chunk of work, and we are dividing that work into the small pieces. It's like this. We are decomposing it. This is exactly same thing we are doing here. So in scope, the only difference in this, the scope chapter, the only difference was that we were decomposing the work into the work packages, which was this. These are the work packages. But further, when we are decomposing these work packages into these activities. See, I'm creating so many activities out of these work packages. So now this is a part of schedule, this chapter. So basically we are keep dividing the one particular, this is one work package 1, 2, and 3. We are keep dividing the work packages into the smallest activities so that we can do the best estimation. So it's I would say the concept of estimation is very important, because you're gonna use this concept in many chapters, and you're gonna see this in exam for sure, and it's gonna be very helpful for you in your own life if you're working as a project manager or scrum master. So you got my understand, so that we are creating many activities. So let me clear this off. So this is exactly we are doing. We are creating it, and now these are the activities I'm writing. And suppose testing page 1. See, I have 1, 2, 3, 4, 5. I have divided my task of one sprint in many activities. Suppose this is a sprint 1, and the sprint is starting 1st January and it's going to 10th of January, and I have these activities for this sprint. And after this activities, once these are done, I have sprint 2, which gonna start from 11 January to suppose 20 January. That's my schedule, and I'm gonna use this pattern so that I can take care of a schedule. I know what I'm doing. I'm tracking everything. We're making sure everything is happening on time. What's the project manager duty is? His duty is whatever the project he get it, he has to make sure whatever the cost he has been given, he has to make sure he's not taking more than that cost. And if a project manager is not doing a project into the schedule. It's all his fault. If a project is behind the schedule, it's all project manager's fault. You can't be like very behind in a schedule. So the reason project managers are hired so that they can give the right amount of estimation when giving this delivering a project. So they have to make sure they are following a schedule and it has to be correct. Okay, so let's talk about more. So first was defining the activities. It means you're telling what these activities are. Designing the page 1, development of page 1 part A, development of page 1 part 2, development of page 1 part 3, and then the testing. So they're gonna sequence these activities because they're gonna write all those activities, but they don't know what the sequence is. So what they're gonna do, the next part is sequence. It means first this will happen, and then this will happen, and then this. It means we are giving a numbers to these. We also call them attributes. Okay, the reason we need a numbering, first of all, we need the sequence activities because we want to know what would happen first, because they can't just start developing part C and they don't have a design, right? So first design has to be completed and part 1 has to be completed. So this is all about sequencing. We should know what we have to do first and then what we're gonna do afterwards. This is all about sequencing activities. There's one more thing you have to know when defining activities and sequencing them. We give them a unique number. When we are sequencing in every single project, you wouldn't see 1, 2, 3, 4. You would see, suppose the project name is Kio. So I would say it's Kio 1, Kio 2, because in one project there can be tons of activities. There can be 2,000 activities. When I was working in projects of 1 year or more, there were more than 600 activities. So definitely you can't go and back to your manager and say that, oh, can we talk about that activity? There was something mentioned, there was something which wasn't done properly. Can we talk about it? So no, you should know the exact attribute, the number of it, so that you can go back. Suppose there is a number Kio 210. So you're not gonna explain this activity to manager. You're gonna or to your senior. You're gonna say, oh, well, I want to talk about KIO 210. Let's talk about it. So it's all about this. And what happened after that? So let me explain the next step on it is sequence activities. I'm going to explain you what I was exactly explaining you, the plan schedule management. It's actually schedule management. So as I have explained in any sprint, we do have the activities. These are the different type of activities which we have discussed for an example, design the page 1, development of page 1 part A, development of page 1 part B, part C, and then testing of page 1. These are our activities, and these are the attributes we are giving. As I have explained, we are giving a different kind of attributes to those specific activity, because if we do have 100 of the activities and we have to refer the activity and we have to find it, we should know the number, because we're not gonna say, hey, I want to talk about testing page 7. No, it can be very hard to find it out if you have, like, suppose 1,000 of activities. So if we know the number, we're gonna say, oh, I want to talk about the activity number 82. This is how we're gonna talk about, and we call this attributes. You can also say this as a unique activity, which means it's a unique identity, I would say, because suppose if the project name is sun, it's just an example. So I'm gonna name this Sun 1, Sun 2, Sun 3, Sun 4, and Sun 5. Here it's going to go on. So it's just like you're giving a unique identity to this specific activity, because when you're talking about some particular activity, what happened, there are tons of the projects in a company going on, and sometimes some activities are left behind or taking more time, or they are more risk. And if they're talking about the activity, they would say, oh, let's talk about activity number 69, or which project you're talking about. That's the reason we give them a unique identity. I'm gonna say, oh, I want to talk about SUN 69. It means then they know they're talking about this project and it's pretty unique. And if I'm in different project and I'm talking about different project, then I can say just moon, MOON, and moon moon 196. I'm talking about this. So that's the reason we give a unique identity, so that we know what we are referring to. And in this chapter of schedule management, what else? So as I have explained, it's define activities. These are So these are the define activities, and this is sequencing activities and giving them a unique identity. These are the first two, and then you're estimating activity durations. It means you're giving an estimation to these activities. You're going to go to the designer for this particular activity. I'm going to ask the designer how much time you're going to take, and suppose he's going to say 1 day. So that would be a duration. And suppose we go to the developer and ask them how many days you're going to take, and he said 2 days. That's a duration. And go to him, he said 2 days, 1 day, or suppose he says 2 days, or he can say anything. Actually, he can say 3 days also, whatever. So we go and ask them about their duration, what's their estimated activity durations on it. And if the project manager is not okay with the activity duration estimates, it can go to that particular person. Suppose I'm a project manager and I'm not okay with this person's days, and it is, so it's 5 days, 6. Okay, so he can, suppose this is 2 and he's saying 4. Just an example. So let's see, I'm just gonna clear this up. Suppose, so he said 4, and I can see it's gonna be 2, 2, 2, 6, 7. So I can give him maximum 3 days, but he's asking for 4. So I have to talk to him and try to negotiate the estimates, because we want to be in a sprint. We can't delay our activities. So that's the role of the project manager. The role of project manager is here that he has to define the activities in all easy terms and easy simple language, and have to make available everything for the team, so that they can give the correct estimation. Because if they're giving the wrong estimations, it's not gonna work out. And then a project management can be left behind on the schedule, and if he's not meeting his schedule, then come on, why we hired the project manager? The reason he's hired, because we want our schedule to be matched. We want this project to be get done in 1 month. It means 1 month. We want the cost to be matched. We want the whole project to be done in $5,000. It means $5,000. No more, no less. 5,000 means 5,000. That's the reason project managers are hired, because the success of the project management is all depends on what the project manager is doing, how they are managing the schedule, and how they are managing the cost. This is all depends on project manager. So let me explain you a little bit more about what is different and what's more in this chapter. The next step would be the develop schedule. Develop schedule is, I'm taking a PMIS software. So it's PMIS software, which is Project Management Information System, which we usually use to put everything in it. Whatever I have talked about, attributes, activities, durations, and who's gonna do I know this is a designer activity, but who's gonna do this activity? Who's gonna do the activity of development, this, and who's gonna do this activity? So we're gonna put, basically we're gonna take all this information and put it into the software. For example, Jira. Jira is one of the software which we use in most of the, I would say actually it's 99% of the multinational company where we use the Jira. I'm gonna, as a project manager, I'm gonna take all this activity and put it into a Jira. I'm gonna write the attributes here, I'm gonna write the activities here, and I'm gonna write the estimation here, or I'm gonna write the name of the person here, and I'm gonna tell, yeah, see, you asked for 2 days, I'm gonna put 2 days as a due date. If you're not done with the within the due date, because there are tons of activities to monitor, this software gonna tell project manager right away, hey, it's now time to review this activity due date is today. That's the reason we put it into a project management software, so that we can track it and we can control it. The last step for this chapter is to control schedule. As we have discussed before, the control schedule is whatever I have planned, to make sure we are working according to that. We're not going slow, we're not going too fast. If we are going too fast, we can control it, or if we're going too slow, we have to fast ourselves using a few strategies. It means we have to control it, and we're going to talk about this. So let's start with the chapter. As we have discussed before about schedule management chapter, we're going to talk, as I have discussed this before, we talked about schedule management plan. We talked about define activities, what it is, and then we're going to sequence those activities. We're going to go for estimate activity durations, develop schedule, which is all a part of a planning, and in schedule control, we're gonna just control, we're gonna make sure whatever we have planned, are we doing according to our planning or not. If our schedule is not according to the planning, we're gonna do a right corrective measures to control it. We have to control it. We can't be too fast, we can't be too slow. We have to be on our time so that we are achieving our goal. So let's talk more about it. What's the plan schedule management? Basically, as I have discussed this before, in the planning, when we are making a plan, the input would come project charter for sure 100%, because we are getting a high level requirement for the schedule from the project charter, which means if the project charter is saying this project has to be done in 3 months, it means it has to be in 3 months. This is a high level requirement we are taking from project charter, and we will be doing breakdown of it. We're gonna take the scope management plan development approach. Obviously, the enterprise environmental factors and the organizational process assets will be there. These are our favorites, right? And the tools and techniques we're gonna take: export judgment, data analysis, and we're gonna do a few meetings with the experts. And our output would be schedule management plan. What you have to know about this is the plan schedule management process. It's nothing more than it involves documenting how you will plan, manage, and control the project to the schedule baseline, and how you will manage the schedule variances. As I have said, it is nothing. In a plan, we're going to talk about all the activities, like define activities. Let me show one more thing to you. So what is basically a schedule? So the way I always recommend everyone to remember this, it's define activities, and then we are sequencing these activities, then we are estimating these activities, or just one, and then we are developing this schedule into a software, which is PMIS software, And once this is done, we are controlling this. Control. It means if we are going too fast, we will control it. If we are going too slow, we will control it. We want to be on our average pace because suppose it's a 3 months project. We want to make sure it would be done in 3 months no matter what. That's our whole huge plan is. What else you need to to know more about the schedule management plan? The key output of this process is a schedule management plan, which can be formal or informal. It is a part of the project management plan and it helps in making the estimation of the schedule for a project. There are particular things you need to know: a schedule methodology and scheduling software to be used on the project. Schedule management plan actually tells us what schedule methodology you are going to use and what kind of software, like a PMIS software, it's Jira or Monday.com, doesn't matter what you are exactly going to use it. As I said, most of the MNCs companies, they go with Jira. A schedule baseline for measuring against as a part of project monitoring and controlling. It means that we are creating a baseline for our schedule against what we can measure it. If I said the project will start from 1st January and it will end on 31st March, that's my baseline is, and it has to be under that. I can't complete my schedule on 5th of April. No, it's gonna be too late, and I should not complete that on 1st of March. It will be too early, right? So we have to be close to our what the target is, and this is exactly and everything you are supposed to know about it. And a couple of more things which you can think about it. The formats and the frequency of project reporting is actually deciding in a project schedule management plan. The next one is define activities. As I have said, what the defined activities are. This process involves taking the work packages created in the WBS and decomposing them into the activities that are required to produce the work packages, deliverables, and thus achieve the project objectives. What it is exactly? Let me explain you in an easy way. Okay, so let me clear this up. Wait a minute. Okay, let me clear this out. I'm gonna tell you what this is. So, do you remember a WBS structure? It basically it gives you a work packages. It says WBS is most like decomposing the whole work of the project into the work packages, and because we want them to get it done, better estimations and everything, we further break down these work packages into the activities like this: activity 1, activity 2, and activity 3. And then here you can say activity 4 or activity 5. So we're gonna further break down these into the activities, and these activities will come here like A1, A2, A3, or A4. This will be a part of, suppose, sprint 1, and in sprint 2 I can put A5 because in one sprint I can complete only a few activities, right? The further activities will come into the next sprint, and it will be a part of next sprint, so it can have a A5, A6 or something. These are the activities. So what we're talking about here now is define activities. We are talking about these activities. Basically, we are defining these activities. We're writing this here, and we're going to work on this. So let's talk more about it. So define activities. The inputs we are taking for this is schedule management plan, scope, baseline, obviously our favorite, environmental factors, OPA. The tools and techniques we're going to use for this is export judgment, decomposition, rolling wave planning and meeting. Before I explain anything else, I would love to explain, as I have already explained the decomposition, it's more like further breakdown of the activities into those activities, because there can be a further breakdown too. There can be A1.1 and then A1.2. It's all about decomposition, and this is our WBS. It means work breakdown structure. What's a rolling wave planning is? Let me explain that to you, and it's a very important topic which you should know for sure 100%, which can come into the exam also. So let me explain. So rolling wave planning, it is a technique. It is simply a technique for a project for which it is better not to plan for the entire project to the smallest detail in advance, but instead to plan a higher level and then develop more detailed plans when the actual work has to be done. In a simple words, let me explain this to you. I hope this one is clear to you, because the WBS was a very important topic. Let me explain the rolling wave planning to you. Well, that's pretty easy too. So what a rolling wave planning is saying, it's saying, so okay, have you ever done on a project that seems to have too many unknown components to adequately break down the work and schedule it? Be careful. When that is the case, you might really have more than one project. Okay, let me tell you in easy words what's a rolling wave planning is. It's like we are rolling like a wave. Just remember this. So it means it's telling us on 1st Jan, I know we're gonna suppose it's from 1st Jan to 30 Jan. I'm just keeping it little small and more concise. So in 1st Jan, I know there's gonna be 3 sprints. Just for example, 1st Jan to suppose 10 Jan, and then I have the next one 11 Jan to 20 Jan, and then I have 20 Jan to 30 Jan. This is what my plan is, right? And then I want I'm a project manager, and to my senior manager I have to give a kind of you can say, what do you say, a kind of report. So what I'm gonna do on suppose on 31st December or on 1st January, I planned each and every small detail of the sprint. I'm telling what I'm doing in this sprint. I talked about the activities, I sequenced them, I know who's doing the activity, I know everything, who's on off or who's not, I know all the details. So I will plan this in detail, but I wouldn't plan this and this sprint in detail. I would just talk a little bit, a kind of, you can say, high level requirement. Suppose I said, here I will make mobile pages, here I will make TV pages, and here I will make phone smart home pages. That's just an example. So I know in this sprint I'm talking about smart home pages, and in this one I'm talking about TV pages, and then this I'm talking about mobile pages. And suppose Apple is releasing Apple TV, Apple Smart Home, and the mobile. So we're going to talk about the mobile in detail because we are in this sprint. We already know we're going to talk about Apple TV here, and we already know we're going to talk about smart home TV here, but we didn't plan about this in detail yet because we are in this sprint. As the time will pass, when I would come in 11 Jan, then I'm going to talk about in detail about the sprint, and when I would go in next sprint, only then I'm going to talk about this sprint in more detail. So this is what the rolling wave planning is. It's like you're rolling with the wave. So when your wave is here, you're only talking about this, and you're more talking about this in detail. You know what's gonna happen in these 2 sprints, but you're not talking about this in detail. So when the wave will push you and you are in this sprint, you're 11 Gen, then you're gonna talk about this sprint. This is exactly what the rolling wave planning is. let's talk more about and what the outputs would be. It would be activity list, activity attributes, and the milestone list. So let me talk about what the attribute list and attributes activity list and the activity attributes are. As I have explained before, these are the activity list. We got this list and we got these list attributes because we are defining the activities. So we got the activities and we got the activities attributes. Like suppose the project name is sun, it's actually you, so it's gonna be sun 1, sun 2, sun 3, sun 4. These are the attributes as we have discussed this before. And this one is also talking about the milestone. What the milestones are all exactly. So there is one thing you need to remember about milestones, which usually appears on exam. So milestones are significant events within the project schedule. They are not work activities and have no duration at all. So I would say remember this line. Milestones, they have no duration at all in milestones. So the defined activities process also involves determining the milestones to use on the project. Milestones are significant events within the project schedule and they do not work activities and have no duration. For example, a completed design, customer imposed due dates for the deliveries, or companies require checkpoint, phase gate, or stage gate could be milestone. Initial milestones are documented in the project charter. Basically, milestones is nothing more than they're saying 1st January to 10 January as soon as you. Okay, so they're okay, let me tell you in an easy way. They're saying when you will be doing, okay, achieve page 1, first milestone has been done. When you have done the page 2, second milestone has to be done, will be achieved, and then you can have a party because you have achieved the second phase of the project, or first phase of the project. And the first phase is the completion of page 1, and the second phase is completion of page 2, and the third phase or milestone can be a completion of page 3 and page 4. So this is a milestone, so it has not a particular work activities and it has no duration because this can take as much as time, right? So it's just like you have achieved a milestone and it has no duration at all. We're going to talk about sequencing activities in the next video. Welcome back, and the next one is sequence activities. The next process involves taking the activities and sequences, and we are going to sequencing them into the order in which the work will be performed. The result is a network diagram, which I'm going to show you right now. But the result, we would have a project schedule network diagram. It's just like saying that we are scheduling our work into a network diagram. Basically, in short, if I have to say, it is so these are so we already have these activities and these are the numbers we're giving to those activities. Basically, we are sequencing this. We are saying this will happen on number 1 and this will happen on number 2. Once this is done, this will happen on number 3 and this will happen on number 4. This is basically, we are saying we are just sequencing these activities. And what else we need to know more about it in this for exam, I would say this is to know, and this is purest form of the this is a purest form of the network diagram, which shows just the dependencies and logical relationship. If someone says, what do you know about which diagram shows the logical relationship, is this diagram. This diagram, we also call this precedence diagramming method, which is over here. So let's start from the inputs. The inputs would be schedule management plan, scope, baseline, activity attributes, which we already talked about, activity list, assumption log, and milestone list of obviously our environmental factors and OPA. So tools and techniques we are using here, precedence diagramming method, what it is exactly. So let me tell you, so this diagram basically is telling is an activity. Once this activity has been done, this activity will happen, and once this activity is done, this activity will happen. So the diagram I have made over here is this. So A is an activity. We also call these nodes. So these boxes, which includes the activities, we call these nodes, and these are obviously the arrows. So the combination of nodes and arrows makes this diagram, and this diagram is not telling more than that once this A activity has been done, the B, it will be converted into the B, and C, it will be converted into this, and then the B will be once the B will be done, we will do C, and once C will be done, we will do E. Once both these activities are done, it's gonna do F. F can't be done if alone D is done. F can't be done if alone E is done. So we have to make sure both these activities are done to make activity F. This is basically is just sequencing that first A will come and then B activity will come. So it's saying F activity can't be completed until D and E is completed. Basically just a creation of a diagram, nothing more than that. There is a couple of more things you need to know for the exam which can appear on an exam, and you need to aware of that. Basically they're going to talk about, let me show you. So for exam, as I said, in its purest form, the network diagram shows just the dependencies, means logical relationship. If on an exam it comes that, oh, which diagram basically, by the way, tells the logical relationship, is the network diagram. If activity durations, if activity duration estimates and leads and lags are added to the diagram later in the schedule management process, it is also shows the critical path. We're going to talk about this for sure, but for now I want you to know about the 4 types of logical relationship. What are the 4 logical relationships we have? We have finish to finish, start to finish, finish to start, and start to finish. Oh, did I miss something? Okay, so the first one is finish to finish. Yes. And then we have start to finish. And then we have start to start. And then we have finish to start. Okay, let's talk about these in detail. So what these basically are saying. So this is finish to start. What it means basically, so finish to start is nothing, it's just an activity finished before the successor can start. Okay, so as I'm saying, finish to start. Finish to start is nothing more than, it's just an activity must finish before a successor can start. What it means basically, so it's saying, suppose we are digging a hole, and once this dig hole activity has been done, only then we can do the second activity, which is plant a tree. So basically it's saying once first activity has been done, only then we can start the second activity. So once the first activity has been finished, only then we can start the second activity. The another one we have is start to start. What it means, so an activity must start before a successor can start. So it means if I start the design, if someone has started the designing, so before a designing has been finished, we can start doing coding, but obviously this will be finished before. So basically it's saying an activity must start before a successor can start. Before this successor can start, before we start doing coding, a design has to be started. Maybe I would have 10 pages to design, but people can start doing code when I'm on my second page. At least 2 pages has been done, right? So they can start picking and making the code of this. So one activity has to be start before a successor activity can start. Let's talk about more. I hope this one is clear to you. Let's talk about the rest of the two. I know my handwriting is pretty bad. Well, let's talk more about it. What else? The next one is finish to finish. What it says? It says an activity must finish before a successor can finish. For example, you must finish testing before you finish documentation. So this is testing, and you must finish testing before you can finish the documentation, because the tester, when they start doing testing, once their testing has been complete, they have to complete the documentation too. But they start the documentation while they're doing testing, but the testing has to be complete before a documentation can be complete. The last one we have is start to finish. What this one is, it means that an activity must start before a successor can finish. This one is rarely used, and you're not gonna see this on your exam for sure. This one is rarely used, but this is basically a saying an activity must start before a successor can finish. It means an accountant has been is training a new accountant, and that activity, this accountant has a training accountant must have start before this accountant leave the job, right? This is basically saying, nothing more than that. Let's talk about another thing. I hope this one is clear. This is an important topic. Okay, so as we get off, so if a question comes and it says how many types of logical relationships in a network diagram is, there are 4 we discussed. And how many types of dependencies we have? Again, we have 4 dependencies: the mandatory dependency, the discretionary dependency / soft logic, external dependency, and internal dependency. We're going to talk more about it. So the mandatory dependency is inherent in the nature. You can say it is a hard logic that, for example, you must design before you can construct or code. It means this has to be done. It's a hard logic. No matter what, it has to be done before you can do the another activity. The second one, which we also call the preferred method and the soft logic, this is a way an organization has chosen to have work performed. There are the other ways it could be done, but this is the preferred approach. What this basically is saying, it's saying we prefer this to get it done before, but it's not a hard and fast rule, but we prefer. So they're soft in a saying. That's the reason it's a soft logic. External dependency is based on the needs and desires of a third party. It means it's not in the hand of a project manager. For example, government and suppliers. If suppliers are late, we can't do anything. They are late. If government changed the rules, we can't do anything. They have changed the rules, right? Internal dependency is based on the needs of the project and maybe something that a project team can control it. Sometimes internal dependency is something can be controlled by a project team. So let's talk a little bit more over here, I would say. Okay, so as I have told for the inputs and in tools and techniques, I've already explained you what the precedence diagramming method. We also call this PDM, just a short form of this. We already talked about the dependency determination and integration. It means the types of dependency, the mandatory, the soft logic, external and internal. We have already talked about it. What's leads and lags? Let's talk about it. So leads and lags. In short, I would say a lead may be used to indicate that an activity can start before its preceded activity is completed. For example, a web page design might be able to start 5 days before the database is finished. Basically, leads is like this activity can be finished before this activity can be started, right? Or so it's basically saying it can an activity can start before the another activity has been completed. What is lag, which usually comes in an exam? Lag is like, I would say, a waiting time between the two activities. Suppose we did cement a wall and now we have to paint it, but you must wait for suppose 5 days for this cement wall to get it dry, this dry wall to get it dry before you can paint it. So there is a waiting period of 5 days. This waiting period is called lags. So that's the reason we call leads and lags. In leads there is no waiting period, and in lags we have waiting period. The next one is PMIS, which is Project Management Information System. Remember, I have talked about the project management information system, which is one of the example is Jira. So let me and it's saying nothing that the thing is whatever information we got it, we're going to put this information into PMIS software. We're going to put exactly the information, the numbering, we're going to put the activities here, we're going to put the duration of these activities, and we're going to put the name, who's going to do this particular activity, we're going to put the due date and everything to track it down. One of the very famous PMIS software is Jira. This is a project schedule network diagram. Is an you can see is a kind of an image depicting the flow of project activities in the logical order in which they will be performed. So basically, project it's a system which helps us in scheduling, tracking, knowing the information, finding the information, to whom it's assigned, these kind of things it tells. What else we have? We have project schedule network diagram, which I have already explained to you, which tells us the performance, when that particular activity and on what number this will be performed. And I would say, to know more for the exam, you should know these things. Management plans provide the approach for estimating. They tell you, which we're going to talk about this in the next one. So let's talk about these in the next video. Talk more about the estimation, but I would like to tell you, for exam you need to remember a couple of things, like management plans provide the approach for estimating. Now we are going to talk about the next topic, which is estimation. Remember, we were talking about the activities, how to sequence those activities and giving them attributes, and how we're gonna give the estimation. So when we are giving estimation, let me show that to you. So these are the activities, as I have said, and then we are sequencing those activities, and then we're gonna do the estimation on that, like 2 days, 1 day, 3 days, 2 days. These are the estimation. So now there are different types of approach which you can use to do the estimation. When project manager asks his or her team, what estimation you want to give to me for this particular activity, a person can use any of the approach, and we're going to talk about those approaches over here. Sometimes company already decided that what kind of approach you have to use, but some companies, they don't have any approach particularly, then you can use your own approach. So let's go ahead. So it's saying the same thing. The management plans provide the approach for estimating. Estimating should be based on WBS. to improve accuracy. So basically it is saying that the estimation has to be on based on WBS to improve the accuracy. For example, I just want to let you know this thing. This is our WBS model, WBS, and then we have work packages. Is just to suppose we have work packages, and then we have further break this down into an activity like A1, A2, A3. I'm just roughly making it so you can understand it, what I'm trying to say. Let me explain. Okay, so this is our WBS. So our activities and the estimation would be on top of that. We definitely gonna estimate each and every single work package and the activity over here. The reason is this, because in a project there has to be a WBS, which we have discussed in the scope chapter, and it has to be estimated. If you're not estimating, it means we're not doing that activity. And all activities, whatever is in WBS, we have to do it anyhow to complete the project. And if something we missed while we were making this WBS, it means that activity has been missed, and now it's not a part of our project right now, but eventually we were supposed to do it. And I'm going to tell you how we're going to deal with it. Do you remember the chapter, the very chapter of integration, where we were talking, if something has been missed from WBS, we would go to the integrated control change board, and they're gonna fix that for us. We're gonna just go with the request, change request to them, and they're gonna fix that up for us. If they're gonna approve it, we're gonna put that activity as a part of WBS over here. If not, then we will just put that in the change log, and that will be over there. And we talked about that. Okay, what else? Identified risk must be considered when estimating the duration, cost, and resource requirements of project work. So it's just saying, when we are giving estimation, we are required to take risk into a consideration. We can't just give the estimation of that right away and forget the risk, because risk is something we need to consider. Let me give an example to you. For example, you get a page. They just show you a kind of image of a page, of a web page, and they just want a developer to work on it. And if the developer wouldn't check it properly, and he didn't realize the risk, he might say, oh, 2 days. But this is a real base scenario, a real base situation. A developer just said, oh, it's gonna take 2 days, and on the very first day after giving estimation, and when the project was started and his first day came, he has realized the designer didn't make the mockups properly. The markup was just an image, it didn't have the elements how the developers work, so he couldn't start his work. So he had to go back to the project manager and the designer to ask for the right markups. And so that was pretty hard, and because he didn't realize the risk out of it, so he couldn't give the better estimation, and that's why the project was delayed. So whenever you are asked to give the estimation of any activity, doesn't matter you're a designer, developer, or tester, you have to consider a risk. And this is project manager's responsibility to make sure they are taking care of the risk and everything else while doing an estimation. Doesn't matter which approach they are using. Estimates are more accurate and smaller size for the components are estimated. What it means trying to tell, so suppose if I'm further breaking this down, this A1 activity into A1.1, 1.2, and 1.3, the smallest activity I would have, it would be easy for me to give an estimation. So if I have a smaller activity, I would give 1 day, 1 day, 1 day. It means that I know this would be total 3 days, right? This is a kind of approach be used, and this is the best approach and the most accurate approach ever when you're giving the estimation. This is definitely a time consuming approach, but as I have said, it's the most accurate approach ever. So what else we have over here? I definitely wanted to go through this document. Whenever possible, estimates should be done by the person doing the work to improve accuracy. It's saying that when a project manager is asking for the estimations, so we're gonna ask for the estimation from the same developer who's gonna do the work, because the estimation is on the basis of that person's knowledge. We don't want someone to estimate it and someone else to work on it, because that someone else, the third person, gonna say, well, I didn't give the estimates, you didn't ask the estimates from me, I would be a little slow, I would be this and blah blah blah. So you have to, or you should get the estimates from the person who is actually going to do the work, so that you do have a right and correct amount of accuracy. Historical information from the past is a key to improve estimates. Many times you would see the same kind of activities from which would be similar to the another project. So what are you going to do in that case? Obviously you're going to go back and you're going to see those historical information, you're going to open your lesson learned, and then you're going to have a kind of a estimation from there, how much another person took how much time to complete that particular activity, what kind of risk and the obstacles that person got it. So we're going to talk about that a lot. So historical information helps a lot too many times. Padding estimate is not acceptable project management practice. What it means, this is basically saying the padding is not allowed at all. What padding is, so if a project manager asks, suppose a developer or tester, how much time you're going to take or how many days you're going to take, can you just give me the estimation? As a project manager is not a technical person, but the project manager know maybe it's going to take 2 days, it's a kind of rough idea. But a tester come back and say, oh, I'm gonna take 5 days, and then manager gonna ask why you need 5 days, it doesn't look like a 5-day task, and the tester gonna say, well, because I don't know about this much. So what the basically role here it is, so the padding is like an extra time a developer or any person is adding into a estimation just for the safe side. But as a project manager, it's your duty that no one add an extra time called padding into an estimation. For example, if as a project manager I have asked for this second activity to a person, how much estimation you want to give, although project manager is sometimes not a technical person, but my judgment or my experience says maybe just 1 day it's gonna take, and the person comes up with 4 days, well, that's a huge gap, and I'm gonna ask them why you're saying 4. Did you analyze the risk and everything? The person said, yeah, I have analyzed the risk, but you never know, oh, surprise can come, so I'm just adding an extra time called padding. Well, it's a big no in an estimation. No one can add padding. So as a project manager, it's your duty to prevent the padding and do not allow at any cost to anyone to add the padding. What's next? Estimates can be impacted by reducing or eliminating risk. Yes, estimates do get impacted. Sometimes some activities they do have a huge kind of a risk, so we do have to take care of the estimation on top of that, and sometimes they don't have much risk, or there are few activities the risk has been done. For example, if someone gave me an activity A, B and C, and they all suppose I have 3 walls and all 3 walls would have a purple color, well, there is a risk we are out of a purple color, and I don't know when the purple color gonna come. Or suppose today is Monday, I know the purple color would come on Thursday, so there is a problem in doing activity 1. But We know on Thursday we're gonna get it. So the risk right now, risk is on B and C also because the purple is not here. But on Thursday, when we do have a purple color, the risk will be eliminated from here. This is exactly what it's trying to say, that when we're doing estimation, we have to take care of the risk too. Project manager must meet any agreed upon estimates. And it's just saying the project manager must meet any agreed upon estimates. We're going to talk about in the next video. We're going to talk about estimation and how we actually estimate our activity durations for the project. Okay, so the inputs for this would be project management plan. Basically, it's a schedule and scope. Project documents, you can see all the list of the documents which gonna require in making of activity durations. I would say your basics has to be clear, only then you would be able to answer the question. Without any doubt, enterprise environmental factors and OPAs would be the inputs. Now there are tools and techniques. Expert judgment and meetings are always there because we need expert judgment advice no matter what. And there would be meetings. If you're meeting people, we would call meeting. You would hardly find any tools and techniques there where you wouldn't find the expert judgment and meeting. And we're going to talk about all these estimations because they're very, very important for the exam, and this will surely come into your exam. So let's talk about this. We know the outputs would be duration of estimates, and the estimates are based on what? We gave the estimates, but what is the basis of those estimates? Those gonna be the output of it, because we always need a supporting document when you're talking about the estimates. Like if a project manager asks a team member and team member said, oh, I'm gonna take 3 days. If a project manager has doubt or something, he can ask for what the basis you have used for this. Okay, so tools and techniques. I would love to explain all these. These are the 4 major. One is analogous estimating, one is parametric estimating, one is 3-point estimating, and one is bottom-up estimating. So let me explain you what it is exactly. So if a project manager comes, I as a project manager go to a developer or someone and I ask them, okay, let me show this to you. So I, as a project manager, go for the second activity to one of the developer and ask how much time you're gonna take to do this work. He comes up with 2 days. Okay, how he come up with 2 days? This is now the thing is what approach that person, a developer, has used. Did he use the analogous approach? Okay, it should be a little dark. Did he use the analogous approach, or he used the another approach, which is parametric approach, or did he use the 3-point estimating or bottom up? So let me explain this to you. What is analogous approach? It's basically based on historical information, and you can use that in project or activity. What it means, okay, I go to a developer and the developer has to give the answer. What developer gonna do? He's gonna look for this activity, and he's gonna look that if in any lesson loan registers or in any another project, if someone ever did this kind of activity ever, he's gonna look for the historical information. So this is basically a historical information plus your own expert judgment, your own judgment. The developer gonna use the own judgment and gonna use the historical information. This is what we call analogous. What is parametric? This is one of the approach too. Sometimes we can just ask, okay, can you tell me how much what's going to be the duration of this particular activity, and that particular activity includes 100, you know that it's going to include 100 lines of code. So sometimes it's also based on the cost. So I go back and look for the historical information, but I just don't look for historical information on the basis of time. In analogous, we use historical information basis of time. Like for example, I go back to the historical information and will try to get the same activity out of it, and I will look for the same activity. And if the activity says 2 days, okay, I'm gonna see, oh okay, the same amount of work was done, okay, it looks similar, let's say 2 days. But in parametric, I have to look for metrics. Just go with the name, it's metrics, which includes maths, numbers, which no one likes. So parametric, it's a historical information, but I want to see how much exactly it cost, how much. Okay, for example, okay, um, suppose if I'm a manager and I'm giving someone a task to paint a house, and I give them 4 walls, and I just asked that person, can you paint those 4 walls? He said yes. He went back into his history of the projects and saw that, oh, 4 walls took basically 5 days, suppose, in total. So he gave the estimation of 5 days in analogous. But when I asked that, okay, it's gonna take 5 days, but what's the exact cost of that? So he has to go back and look for the historical information, but now the metric thing, like per wall, how many boxes would be there of the paint, and how much per dollar is the amount of that particular box. So I'm talking about numbers, right? Like dollars. I'm talking about dollars. I'm talking about number per liter, or number per kilogram, or number per whatever. When the metric comes, it means we are talking about parametric. To analogous, sometimes we also call this top-down approach. If someone just asks you, what's the another name of the analogous estimating, it's a top-down approach. And it's basically, see, the parametric is historical information, but only the mathematical, like cost per line of code or cost per linear meter. And usually we use this for particularly activities only. But although the analogous, we use it for the project and activity, what it means is we use parametric only for the activities. But although we use analogous for activities plus the whole project. Okay, so the next one says it is 3-point estimating. What it means exactly, what the 3-point estimating is, the 3-point estimating, there is a 2 formula which usually appear on exam for sure. Either you're gonna see this formula or you're gonna see this formula, and there's a trick to remember this formula. But before that formula, I would love to explain you a bottom-up estimating. It's just because I'm gonna remove the diagram. So before I explain the 3-point estimating, I would love to explain you the bottom-up estimating, what this estimating basically is. So this estimating says it is based on the WPS, and it's more expensive but more accurate. Just to let you know, the most cheap or the inexpensive, which is not expensive at all, the very cheap estimation is analogous, because it's just you have to go into the history and look for the historical information, and you just get the estimating right away. Bottom up estimating is the most accurate, most correct, but the most expensive, most time consuming. I would say I'm going to repeat my words, it's most time consuming also, but this is more correct because we want the estimation to be correct. The reason is this, because if you're giving a correct estimation, the schedule will be on the point. If you're just doing a guess, the schedule is not gonna work the way it is supposed to work. Bottom up means first of we're gonna go from bottom to up. It means we're gonna give the estimation of this and this and this. If I do have an estimation of these three, I suppose 1, 1 and 1, which is total 3, I automatically have an estimation of A1. Suppose then I got an estimation of these A2 and A3, it means I have a all total up of this, I already have an estimation of this. So this is like bottom up, we are going from bottom to top, and this is a very expensive and time consuming process. So this is what the bottom up approach is. Now we're going to talk more about the 3.1. Let me explain you how this basically works. So 3 is nothing more than statistically this is very small probability of completing a project. So okay, there are two formulas. One is we call triangular distribution. I'm going to write the word triangular distribution, or we call simple, or we call average. Oh yeah, I mean I would say just simple average. Okay, so these are the two words we use it for one formula, and the formula is nothing more than it's saying what is, if I ask you how many days you're gonna take to complete this project, I would say most likely I would take this much. Okay, what else? Very optimistic, if everything goes good, I will take this much. If everything goes wrong, I will take this much. That's my estimation. And the formula is exactly this. It's P means the worst. If everything goes wrong, this is my worst estimate. If everything goes good, this is my best estimate. And if things are normal, most likely I'm gonna finish on this. So that's my formula is P plus M plus O divide by 3. Why divide by 3? Because it's 1, 2, and 3. This formula usually come up on an exam. This or either the another formula which I'm going to show you. You're gonna get either this one or the another one. So you're gonna get the value of P, you're gonna get the value of M, which is most likely. P stands for pessimistic, M stands for most likely, and O stands for optimistic. Optimistic, we all know it's more like positive, happy. That's the reason we have. So P plus M plus 0 divided by 3. If the value of P is 4, or the value of what? M is 4, and suppose it is what? 3? So how it's gonna be? It's gonna be 11. Oh, just say 4 divided by 3. It would be easy for me to calculate. It will be 12 divided by 3, and it would be 4. Okay, that's our values. Okay, the next formula we have, it's pretty easy, but they usually use these words, the beta or the weighted average. If they use simple average or the triangular, we're gonna use this formula. If they use the word beta or weighted average, we're gonna use this formula. P, which is the worst case, O, which is the best case, most likely, which is most likely, but this formula says I give more importance to this most likely. The reason is this, I'm saying the worst case is this, the best case is this, but most likely, and I'm very sure this would happen, and I'm giving this most likely 4 times more than these 2 soldiers. So it would be divided by 6. The reason, because it's 4, M plus 1 and 1, it's going to be 6. So this is the formula P plus 4 times of M plus, oh, so if in this it would be 4 plus 4 into 4 plus 4 divided by 6. I'm just taking the same, and then we're gonna just solve this out. This is all the formula is. I'm gonna delete this. I hope this one is clear, because you're gonna see either of this formula on the exam for sure, 101%. Either you're gonna see the simple one, or you're gonna see the beta one. Okay, so now there is a thing to think about it. What is the role of manager in estimating? If developers, designer, or the whole team or testers, they have to give the estimation what exactly the project manager is doing. He has to make sure, and he has to provide the team with enough information to properly estimate each activity. If he's not providing the enough information to the team is not going to give the right estimates, and if team doesn't give the right estimates, project manager would end up messing up a schedule. And the reason project managers are hired, because they should complete the project on the time, complete a sanity check after estimates, just to making sure the estimates which were given by the team is absolutely correct and prevent padding. Project manager has to make sure there is no padding in the estimates, because estimates should be padding free, as we have discussed before. Make sure assumptions made during the estimations are recorded for the later review. The reason, because if project manager asks for the estimates right now from, suppose, a tester, and tester says 2 days, project manager should write it in the software or whatever thing he's using. It has to be recorded. Recorded means not just record the voice, it means it should be noted down on a paper, or it's something, in a software. A multinational company use the Jira PMIS software, and they just record that into it so that everyone can see it, so that the tester later on, after a few days, he can't say that, oh, I said 3 days, you just noted down 2 days. So it doesn't work like this. That's the reason project manager has to record it. And I believe this one is done. And we have already discussed what the alternative analyses are, what the resolve analyses are. We already discussed about this, but if I have to give the glance to you, I would say the alternative analysis is when activity estimates are not acceptable within the constraints of the project. We start looking for alternative options to complete that work, basically. Resolve analysis, it's nothing, it's like estimation helps us to identify more risk, and risk management, which we're going to talk about this more in a risk chapter, reduces the uncertainty in time and cost estimates. This is accomplished by evaluating and planning for significant opportunities and threats. We're going to talk about this in risk chapter, but for now I would just say resolve analysis is just like we are keeping something as a resolve. I have talked about this before in the course, but in short, if I have to say, it's suppose for doing a particular activity, we are going to paint suppose we are going to paint a house, and the house painting would take $10,000, but I'm gonna ask for some resolve, which we'll call contingency resolve. It would be contingency resolve because I know we're painting a house, but if any day the rain would come, and the workers are working, they have to go back home, but I would have to pay them, right? So because it's September, it's a rainy season, and workers are painting outside the exterior of the house, and the rain suddenly comes, they have to go back to home, but because they were on work, so I have to pay them for that extra day. So I would keep $2,000 extra in my pocket for them just in case a risk of a rain comes. But if a risk of rain doesn't come, this is unused money, and I would just give it back to the person, whoever is paying for the or funding for the project. We will use only $10,000, but if an emergency comes and we know the risk, we kept it for the rain, we're gonna use this for that particular day. And in detail, if I not I would say in a detail, but if I have to dig more into it, we do have one more kind of a reserve, says management reserve. So what's the difference between contingency and management reserve? Well, I knew that rain can come or it would not come. If rain would come, we would use this $2,000, which is called contingency reserve. It's a risk, it's a known risk. It's a known risk, and I know about it, and I know rain can come, so I'm keeping $2,000 extra. But if rain doesn't come, I'm gonna return this money. What's a management reserve? It means I'm keeping, suppose, $3,000 extra as a management reserve for an unknown risk. What can be unknown risk? Unknown risk can be earthquake. Earthquake can come, or a flood can come. We didn't expect any flood, or there is no river at all, but any unknown risk can come, and we have to. You know what a biggest example of unknown risk is? COVID. COVID was unknown risk. So if a pandemic, something like this, which is unknown to the public or unknown to anyone, comes up, we have to use our management reserve to cover up our cost. This is exactly what the reserve analyses are, and from time to time we just see that if we are using the reserve, either it is contingency or it's a management reserve. If we didn't use it, we're just gonna give it back. That's it. So, and the outputs, as I said, the output of this would be duration estimates and the basis of estimate. It means what are the basis of estimation we have used to make the decision of the estimates. And it's totally up to the person what kind of technique they want to use. But as I have told you, the bottom up is the best one out of all those, and the cheapest one is analogous. So keep this in mind, and let's go to another video. Talk about develop schedule, which is next. So what basically we are doing now. So in short, I would say, remember we already talked about define activities, and then we are sequencing those activities in the line, and then we are giving a duration estimate, which can be anything. Now we have all the information. We have to develop this schedule, which is the next step. Develop schedule means whatever we have talked about here, those sequences, activities, and the estimate duration, we're going to take a PMIS software. It is this. Usually the multinational companies, they use this one, Jira, and we're going to take all this information and put this into this software so that we can track it properly, and we know who is particularly doing this activity or this activity. This is exactly just to put everything into the software and track it, and that's what the develop schedule is, and that's it. So let's talk more about it. So the inputs for this would be project management plan, basically the schedule management plan, the scope baseline, projects documents, the documents you might gonna need it to when you're making a schedule. You know you're gonna need the activity attributes, activity list, assumption log, basis of estimates, duration of estimates, which were the outputs of the previous duration estimation activity thing, the lesson learned register, milestones. The reason we know we need the lesson learned register is just because we want to know how, when someone developed the schedule in the past, what information they got it or what obstacles they had to see it. Okay, the project schedule, network diagrams, the project team, and so on. We're gonna need the agreements also. The reason we need agreement, because we when we are making a schedule, we are making sure, okay, in agreement, if we had talked about only 1 month, it means the schedule we have made, it is according to 1 month. It is not less, it is not more than that. Our favorites, enterprise environmental factors, the OPAs also, the tools and techniques. Now here the important things comes. We're going to talk about the tools and techniques here, which is schedule, network analysis, and so on, the critical path method, the resource optimization. We're going to talk more about it. And we know the output of this would be schedule. We got this, we have to make and develop a schedule. We are making a schedule. We would have a schedule, project schedule data for sure, all the estimates and the activities, schedule baseline. It means it has been approved. We're going to talk more about it. Let's start with schedule, network, and before that, actually yes, let's go with schedule, network analysis, and this would help you a lot to understand what basically we are looking. So basically, schedule, network analysis, it is used to create a schedule model and ultimately to finalize the project schedule. And there are few tools and techniques we can use it to make a schedule network analysis. There are, so for example, I'm just gonna clear this up. So we're going to talk more about what kind of tools and techniques we can use when we are doing a schedule network analysis. Basically, if I say the task or the project is of 1 month, fine. And there could be many activities. Remember, we talked about many activities. So suppose one activity I know gonna take me 20 days. And another activity is gonna take me 25 days. And one more activity gonna take me 15 days. So if someone come to you and ask how much time exactly you're gonna take to complete this project, what I would say, 15 plus 20 plus 25? No. We're not gonna do that. We're gonna say, because this is the longest activity out of all, I'm gonna say it's gonna take 25 days, because in 25 days this 15 days are getting covered and 20 days are getting covered. Suppose this activity took 17 days instead of 15 days because I got some a kind of a risk or obstacles. That's completely fine. Anyhow, it is less than 25 days when someone asks me, and these all activities are going parallel. So when someone asks me how much time total you're going to take to complete this project, my answer would be 25, because that is the longest activity. And just to let you know, there is a word named critical path, and which is a very important topic for the exam. The critical path method involves determining the longest duration path through the network diagram. The earliest, latest an activity can start, the earliest and latest it can be completed. I would say concentrate on my words as I'm going to repeat it again. It is the longest duration path through the network diagram, the earliest and the latest an activity can start, and the earliest and latest an activity can be completed. So as this is the longest path we have, this would be critical path. This would be our critical path. It means if I got obstacles in this path and I'm delayed by 1 day, it means my project and my commitment of saying 25 days would be not valid anymore, and suppose I'm late by 1 day, then it's going to be 26, and my reputation in front of customer would not be good because I promised this to be 25 days. So I will put more concentration and more resources, and this will on this, and this will be more critical because I want this to be completed in 25 days no matter what. It can be a little early, but no matter what, I want this to get it done on time. So that's the reason it's very critical. It's critical path. And sometimes there is a nearby critical path. For example, I do have one more activity which is taking 23 days, which is very close to this activity. We're going to call this nearby critical path. Why this is near critical path? Because if this activity has been delayed, suppose by 3 days, it can become my critical path, right? And because it's very near, the difference is very near. First, our concentration will be on this, the critical path, and the second concentration will be on this, the near critical path, to make sure it is not becoming a critical path and we are completing this all within the time limit. And now this is project manager's responsibility to complete these tasks within the time range. Let me tell you one more thing. So there can be a question, how many critical paths can be in a one project? There can be as many as there can be. We do have right now one critical path of 25 days, and we can have one more critical path of 25 days and one more. So suppose I do have three activities, which all these three activities gonna take 25 days each. So all these three activities are my critical path, and the near critical path would be still 23, which is less than 25. So there can be as many as critical path into a project. The only thing is we do have to take care in our mind, if we have more critical path, so more critical path is equal to more risk. We have more risk. So if we do have a more critical path in a project, so it means we do have a more risk to manage and we have to take care of it. Okay, I'm gonna tell you a couple of more points which gonna appear on exam, and it's very, very important. So let's go ahead and just give it a try. So as I said, I'm just making a diagram again. This is a critical path, CP, and another one is suppose 22, nearby critical path. The another one I have 15. Another one maybe I have it for 20. Okay, now we're gonna talk about this. Now I'm gonna talk about one more concept, which is float, which usually come into an exam. So what is float basically? We do have three kind of floats. We do have free, total, and project. The easy way to remember this is FTP. It's free, total, project. What it means basically, what the free float is. Free float is the amount of an activity can be delayed without delaying the early start date of a successor. What it means basically, okay, so it means a free float. It is saying the total amount of time and activity can be delayed without delaying the project. Oh no, free float is an amount of an activity. An activity can be delayed without delaying the early start date of its successor. It means suppose I've got 5 days to do a task, 1, 2, 3, 4, 5, and on 6th day the new activity has to be started which will be depend on this activity. I got total of 5 days to do that. It's my wish if I start on 1st or 2nd. Suppose I start this activity on 4, the first 3 days I just did rest, but I have to make sure if it's starting late, it's not ending late. Anyhow, by the end of 5th day, I have to complete this activity because my starting can be late. My starting of this activity can be late, but starting of another activity can't be delayed. So it doesn't matter which day I'm starting, I have to finish this on 5th, because on the 6th day another activity gonna start, which will be depend on this. So free float is the amount of an activity. I can be delayed as much as I can start on any day, as long as I'm completing on 5th, everything is fine. This is what the free float exactly means. Now we do have a total float. What the total float says, the total float is the amount of time an activity can be delayed without delaying a project date. So basically what it means, we do have different activities, and in free float we have said this activity we can start late, but we would complete this on time because we want this activity to get started on time. The total float, it's just like these are the definitions you need to remember for your exam, because this usually appears on an exam and they just want to ask you what this means. So you are supposed to know. So the total float is saying that this can delay. Maybe suppose someone did this on 6th day instead of 5th day, and this activity now is getting started on 7th day instead of 6th day. So now my activities can be delayed, but whatever the project submission date, suppose I got 1 month and on 30th January I have to submit the whole project, my activities could be delayed, but I'll make sure I'm not passing this 30th of January, and I'm giving this project submission to my senior managers by that particular date. It is what the total float is. And last float we do have is a project float. Project float is the amount of a time a project can be delayed without delaying the externally imposed project completion date or a date requested by a customer. Very easy in this. Now, as a project manager, remember in total we talked about that by 30th I have to submit this to my senior, because that's what I committed to. But sometimes the project float is saying the whole project has been delayed, this activity was delayed, this was delayed, and even I passed this activity, but the senior management or the company CEOs or someone committed with the customer. Suppose they gave me this 30th January as a deadline, I have to submit it, and they're submitting on 15th February to the customer. So the project float says I might gonna delay this and gonna submit on 2nd February. I have delayed the project, but this would not be delayed, because if we are in front of customer, the customer has to get the thing on the time, otherwise our reputation will be gone, right? So we're going to talk about this more in the next one, and I'm going to talk more about the formula which usually appear on an exam, so stay tuned. Welcome back. So now we're going to talk more about critical path. I really want you to see the screen and just think about it, which can be critical path. You know what? You're right here. So this one will be completed in 25 days. This is our critical path. And this one is also taking 25 days. The most longest time it is taking to complete a task. This one is critical path too. So we can say this, that it's going to take 25 days to complete this task, complete this particular project. And as a project manager, I said to my senior manager, it's going to take 25 days to complete this project because these are the most longest activity ever taking. So with this activity, which is a near critical path, this can be a little bit delayed, as I have said. So suppose my one worker or one person is sick and my one of the activities little slow down. So this activity can be slowed down till what time? Till 25, because on 25th day we have to submit it. So this activity has a float is equal to flexibility. Just remember this. Float is equal to flexibility, F and F. So this would have a flexibility of 4 days, that this can be maximum delayed up to 4 days. If a person is taking a sick call, that person can maximum wait till 4 days, but it has to be done by 25th day because that's our critical path, that's the deadline of our project is. So if I ask you to calculate a float in this activity, what would be that? So it's gonna take 20 days. It does has few float of 5 days. This one has a float of 6 days. It means it does has a flexibility of it. So what's gonna be float in a critical path? It's gonna be 0. There is no float because it's itself is 25 days, and that's the project deadline timelines are 25 days. So the float into this gonna be 0. So let's talk more about that. I'm just gonna. So there are a few formulas which you need to remember for your exam, which usually appear in your exam, and sometimes they just ask you to calculate a float. Now you know what the exactly float is. Float is a kind of flexibility, and there is a formula to remember the float. So what the formula is, let me write this, float and float, because there are two formulas to remember for the float. Now I'll give you a very easy way to remember this. So how I remember is S means start and F means finish. So S means start and F means finish. Wow, look at my handwriting. Okay, so F means finish. So the formula now is, just concentrate on this, LE and LE. That's exactly our formula is. It says the late float is equal to late start minus early start. So if there is a S, there would be an S. If there is a start, it will be minus from start. If it's finish, it will be minus from finish. That's what you need to remember. And it is always LE. So it's late start minus early start. And another formula is late finish minus early finish. The reason there are two formulas because there are two ways to calculate it. If in an exam you have been given LS and ES, you're gonna minus this from this, and if you have given this and this, you're gonna just minus. Just remember, late is always minus the early. Early will come after that and it would be subtracted from the late. But if it's finish, it has to be finish. If it's start, it has to be start. This is very important to remember for the exam. And let's talk more. What I'm gonna do, I'm gonna just write this formula on a peak side. So it's float, it's LS minus ES, excuse my handwriting, or it's gonna be LF minus minus EF. There you go. So I'm going to talk more about it, what it is exactly. So see, these are the formulas you need to remember, and you already know the critical path has no float at all. What other things you need to remember? But before you remember, I'm going to show you one more thing. So you know what we are talking about? We are all talking about the schedule, how we're gonna create a schedule network diagram, a schedule network analysis. One of the tool and technique to do the schedule analysis is critical path method. We also call this CPM, but this is not our technique. I would say it's just a short form. You might not gonna see this CPM on an exam, but it's a critical path method. Just a term, you're not gonna see the CPM, but you will definitely see the question from critical path method for sure, 100%. Another technique, so I also want to show you what's the actual, how they make the network diagram. Okay, remember I have showed you a thing. This activity will happen first, this activity, and then this activity and this activity, and we give the sequence to those activities, that this is gonna happen first, and then this will come, and then developer will do this, and then tester will do this. So how they create this in a schedule network diagram, and I have showed that diagram to you. It means you're doing this, and then you are doing this, and then you are doing this. This is exactly what the diagram means. Okay, let's talk more about it. And I'm gonna show you a diagram which might gonna appear on an exam, which might gonna look like this. So let's concentrate on this one. Okay, there you go. So concentrate on these boxes. This is early start and this is early finish. Remember we were talking about the formula, so this is exactly the formula is. And this is late start and this would be late finish. Okay, now we don't know the numbers, we have to figure out the numbers, and this activity might gonna appear on exam, but before we start I want you to calculate a critical path method here. So how many paths you're taking a look, you can see over there. It starts from A, go to B, E, H, J, K, which is this. It means it's 19. If how come I got 19? It's 3 plus 6 plus 2 plus 3 plus 3 and plus 2 is equal to 19. These are the durations. I got it automatically. So on an exam you will get the durations, and it can be in days, like 3 days, or it can be 3 months or 3 years. Usually it's in days or in months usually. The another path you are seeing is A, C, F, H, J, and K. This is the second path you are seeing, which is here, and it's gonna be 22 days of total because we're gonna do the total now. The last path which you can see here is start from A, D, G, I, and then K, which is here, which is the total would be 21. It's very easy to calculate which one would be a critical path method. Obviously the 22 is the highest number, so this ACFHJK would be our critical path method, which is 3 plus 7 plus 4, 3, 3, and 2 is our critical path method. So we will concentrate on this for sure. What else we need to know about it? Okay, so we're gonna start. Let's take red. We're gonna start with number 1. There are tons of another methods to do it and to deal with it, but we will start with number 1, because it's always easy when you're counting something, and if I ask you, please can you count how many bottle of water you have, you're going to start with 1 2 3 4. You're not going to start with 0. There is a way to do and start with 0, but that would be very complicated. So it's always good to start with 1, and that's my personal recommendation too. So let's start with 1, and you already have this 3. So the formula here comes is early start, which is 1, plus du, which is this, minus 1, because we are going in a forward direction. So let me write this up for you over here. So sorry about this. So if we are going in forward direction, what do you mean by forward direction? The forward direction, say, is going from this side to this. When we are going from forward direction, we do have a formula of ES, which is early start, plus the duration, which is mentioned to us, minus 1. This is our forward formula, which we usually use it. We do have a backward formula too, but I really want you to concentrate on forward formula, and let's start with that for now. So there we go. What do we have? Okay, so if we have 1 plus 3 minus 1, how much it's gonna be? Obviously it's gonna be 3. Okay, so it's gonna be 3 over here. So what's gonna come over here? After 3, 4 comes. So we're gonna put, because A is getting divided into 3 parts, we're gonna put 4, 4, and 4. We're gonna do the same with this 4 plus 9 minus 1. It's gonna be 12. 4 plus 7 minus 1, it's gonna be 10. 4 plus 6 minus 1, it's gonna be 9. Now, after 9, it's gonna be 10 here, because after 9, 10 counts. After 10 here, it's gonna be 11, because these all are going in different boxes. And after 12, the next number would be 13. Now a twist is about to come. So 10 plus 2 minus 1, 11. 11 plus 4 minus 1, 14. I'm gonna do this one too, it's 13. After 13, it's very clear the 14 would come, but what's gonna come over here? Because after 11, 12 comes, but after 14, 15 comes. So what's gonna come? Let me tell you. So the 15 gonna come because this will be done on the 11th day, and this will be done on the 14th day. But this activity, number H, can't start until F has been finished, which is gonna be done on the 14th day. And then we're going to start on 15th day. That's the reason we have 15 here. So 15 plus 3 minus 1 will be 17. And we're going to have 18 here. 18 plus 3 minus 1 will be 20. Now when here it's going to come 19. Obviously, we have 19 here, we have 20 here. We're going to have 21 over here, because this activity gonna take 20 days to get complete, so we have to start this on 21. And 21 plus 2 minus 1 will be 22. Have you noticed one thing? This is 22. The end result is 22, and the critical path method, we do had this one 22 also. If this doesn't match, if the duration and this thing, which is early finish, doesn't match, we do have to make sure that our calculation is right. If our calculation is not right, it means we have done something wrong, and we have to go back and do that. Now there is a backward, I would say, now there is a backward formula too. We went into the forward, and now we have a backward formula, which is late finish minus duration plus 1. Let me show you how it's gonna work out. So here we're gonna do that. We're gonna put, let's change color, black or this. I want a different color. Okay, let's try this. So it's gonna be 22 plus 2. Oh no, it's 22 minus 2, which is going to be 20 plus 1. Remember the formula? It's early finish minus du plus 1. There is a very great way to remember these formulas. When we're going forward, see, when we're going from A to suppose F or whatever it is, when we're going forward, we have too much in our basket in the starting and we are emptying that basket. So that's why we're gonna do -1. As soon as we are moving forward, we want our basket to get empty. On a number B, I'm gonna take one more item out of my basket, and on number C, I'm gonna take one more item out of my basket. So that's the reason we have -1 here. And when I'm going backward, my basket is already empty. I have to add something into my basket. So as soon as I'm going step by step back, I'm keep adding +1, +1, +1 items into my basket. That's the reason this is how this formula has been derived. It really helped me in learning this. So I hope this is going to be helpful to you too. So that's exactly formula is. What we're going to get here, just the formula 21. What we're gonna get it here, the one thing less, 20, and 20 minus 3 plus 1, it will be 18. I'm just gonna do the all numbers. It's gonna come 17 here, and it's gonna come 15 here. I'm just doing a calculation too. So from here it's 21, so 20 gonna come here, 15 gonna come here. I have to show you very interesting thing which is about to come. So I'm sorry, it's actually 13 and it's 5. So 15, it's gonna be 14, and it's gonna be 14, and it's gonna be 13, and it's gonna be 11, and it's gonna be 10, it's gonna be 4, it's gonna be 3, it's gonna be 1. Now the float formula comes into an existing now. Do you remember the formula? I want you to see the formula. Late start minus early start. What it says, late start minus early start. 1 minus 1, it's gonna be 0. 3 minus 3, it's gonna be 0. 4 minus 4, it's gonna be 0. You will notice in this critical path, any of the activity, 15 minus 15, it's 0. The float is 0, and critical path float is always 0 no matter what. If it's not coming 0, it means you have done some calculation mistake. So this one has always a float 0. 22 minus 22, 0. 18 minus 18, it's 0. That's the formula to calculate a float. Now let me show you one more thing. So you already know in this is a critical path. You don't need, there is no float, it's critical path. It has maximum days and the project will be done in 22 days. And you already know 22 minus 1, you do have a float of 1 day here, and you do have a float of 2 days here. So let's see if, I mean, this is a quickest way to calculate it, and the way I've showed you is a long way, but all the basics has to be clear, right? So let's go with this ABE, this one. So you would notice, except the critical path, how much float we have? 14. Oh yeah, it's actually 3 days, sorry, it's 3 days. So 14 minus 11, it's 3. 13 minus 10, it's 3. 12 minus 9, it's 3. 7 minus 4, it's 3. So we do have a float of 3 days over here, and it's always going to be same until unless it's a critical path. And on this one, which is ADGIF, 20 minus 1, 19, it's going to be 1. 14 minus 13, 1. 15 minus 14, 1. So it's always going to be 1. The way I have showed you here is the quickest, easiest method, and this boxes which I have shown you is the more detailed method to understand it. In case something shows up or comes up on an exam, you are prepared for that. So let's talk more about it. There are a few more things I would love to explain it. So milestone, bar chart, and the network diagram. Let me explain you these things too, because this might gonna come on an exam and you should be all prepared, right? So let me just take this away. And we're gonna talk about these. Do you remember? I'm sure you do remember the critical path method. Remember, this shows the boxes and it has arrows and like, yeah, this is what it shows. It shows the interrelationship between the activities, and these are the arrows. We also call these activities nodes, and these are arrows. What this kind of thing is, the network diagram is to show the interdependencies. This is what you need to remember. Okay, so what else you need to remember? There are a kind of charts which you can see on an exam, and they can just ask you what the bar chart, why we use the bar chart. So let me tell you what the bar chart is exactly and how it's gonna look. I wouldn't have an exact picture of it, but I'm gonna show that to you. The bar chart and the milestone chart. This is very important, that might gonna come on an exam. So let's talk about it. Just one second. Okay, so let me explain this to you. Let's go with bar chart, but this is something you need to remember. So the bar chart, it says these are the bar charts. We just show something on a bar chart. When we make a bar chart report, which we make a bar chart report, this report is definitely not to show the planning tools, so no planning tools at all, but they're very effective for progress reporting. If we are showing progress or reporting and we want to control something, so I'm showing that in January our progress was this, in March we had this much progress, and in April our supposed progress is, it has been increased again, and in May we had this much progress. So bar chart is actually, it's an effective tool to show the progress reporting and control. So this is not a project management plan tool, this is a progress reporting tool. This is what you have to remember, and I have wrote it over here too, that the bar chart is to track the progress or to report to the team what's the progress of our particular team is and how they're responding to it. So this is why we used it. So there is one more thing to remember. There is also a milestone chart. Why we use milestone? Let me tell you what the milestone exactly means. Suppose it's December, January, Feb, March, or April, and I'm saying, okay, we will start in December, and in January all requirements will be gathered. That is our second milestone. We will do coding, and by February our coding will be done. Testing, our testing will be done by May. These are the milestones. And why we use milestones report? What's the main reason to use this milestones report? So these are basically our good reporting tool to management and stakeholders or customers. The reason is we use the milestone as a reporting tool to management and customers because we are showing them a graph, and a graph says, well, in December we're gonna achieve this milestone, in January we're gonna achieve this milestone, and February a recording will be done by February. These kind of things we're gonna report it to our seniors. There we go, we're done with this, right? So milestones, bar chart, and the network diagram. Now there is a very good thing which you need to remember for your exam. This is last for this topic. Let's complete this one. Okay, so this is what we call schedule compression. This is very important, and I would say you need to remember this. So let's talk about this. My favorite board, whiteboard. And I hope everything is clear. Just to let you know, if anything is not clear to you, please feel free to reach to me, and I'm here to help you out. So now I'm telling you, the project starts on 1st January, and as a project manager, I have to report and complete the project by 31st of Jan. That's my deadline, and I got only 1 month to complete the project. And I started on Jan 1st, and I know on 31st it will be completed. I'm not gonna just leave the way it is. I will come on Jan 10th to see if 40% has been complete. Suppose I have planned already that I will come on Jan 25th and Jan 10th, and 25% has to be complete. And if I have come on 20th of Jan, 75% has to be complete because I have to deliver it on 31st of January. That's my goal is. Suppose, just an example, I come on January 10th, but I'm not done with 25%. I have just finished 10%. Suppose, well, I'm behind the schedule. I need to do something, because if I'm going with this pace, I have done only 10%. Well, I'm not gonna deliver on 31st. I might gonna deliver on 10th Feb. But as a project manager, they hired me literally to give the delivery of the project on time. So I have to do something. I figured that out on January 10th. Well, this is not what I want, right? I have to do something. I have to do schedule compression things. So let me show that to you what it is. We call this schedule compression technique. I'm gonna say there, schedule compression. So now there are two techniques to control it. One is crash and one is fast track. Now it's up to me which one I should use it. So one is fast and another is crash. What this basically means, so as you can see in crash, okay, let's start with fast tracking. So in fast tracking, you will see in normal, one person is working from 1 to 5. This is what I planned. And then second person will do the second activity, start on the 6th and will go till 10th. And the third person will start the activity once this person is done on 11th, and then will done on 15th. That was my original plan, but I have seen this is not happening. I'm delayed, or maybe the customer changed their mind and they want this to get it done as soon as we can. So I'm gonna do fast tracking. Fast tracking is one of the technique where risk is very high. What I'm doing right now, the first person is still working on an activity taking 5 days, 1, 2, 3, 4, 5. But I'm saying to the another person, comes on the 4th day and start doing work. Whatever this first person has finished on first 3 days, start working on those work and just start working on these things, and whatever this person is doing on 4th and 5th, you're gonna do it once you're done with the first one. So basically I'm saying to that person, the first person has to do this much, so second will, instead of waiting for first person and start the work, I want the second persons to start work on this so that he can save some time, and I want another person to start work over here to catch this much work. He will start working on it, but there is a high risk. There is a risk. Why there is a risk? Because there is a chance when the second person comes, he might gonna forget to take this number 4 and 5 properly. He might gonna would not be able to implement it properly. So that's a high risk. It's a high risk of forgetting and high risk of missing some important information. There is another technique which is crashing. Instead of one activity take 5 days, I want that activity to get it done in 3 days. How come? I'm gonna put 2 people or 3 people, so it's going to increase the cost because I have more resources to do this particular task. They're going to complete in 3 days, but more people would be needed. And then the next activity would start after third, and there are going to be like more people going to do the same activity. We are crashing everything, but this is going to increase our cost. So if in an exam a question come, you as a project manager, you have to use a kind of technique to control the schedule. You have to control the schedule. These are the schedule controlling techniques, and sometimes you have to control these techniques. So they're saying you have to use the technique, and you have there is no limit on budget, but you have to be easy on risk. It means we can go with crashing because we are easy on, there is no limit on budget, we can use the high cost, but we can't take a risk. And sometimes they say, oh, there's we don't have much budget, but you have to control using schedule compression techniques. Then we're going to use the fast tracking, because fast tracking is all about high risk and crashing is all about high cost. And let's go to the another one on the next video. Talk about control schedule, but before I talk to control schedule, I forgot to tell you one important thing about a schedule baseline. I really want to tell you, we do have 3 baselines. See, we do have a schedule baseline. We do have 3 baselines. One is scope, another one is schedule, and the last one is cost. We have already discussed about the scope one. If you remember, it's a confirmed scope statement plus the WBS and plus the WBS dictionary. I hope you remember this. The schedule is nothing more than it's a version of the schedule model used to manage the project. It is what the project's team performance is measured against. It's a part of a planning. So whenever we are measuring against what we are supposed to measure against, it is schedule baseline. So once we have a schedule baseline, we can't change it unless we go to the CCP board, because it's an approved baseline. The baseline, just think about it, whenever the word baseline comes, it's an approved version of whether it's cost, schedule, or scope, and it can't be changed until we get a permission from CCP board to change it. We need a permission, but before a baseline has been established, we can change whatever we want. So now it's time to control the schedule. Whatever we had planned in our planning session for the schedule. Now we are going to compare it against it, and we're gonna see if we need the schedule compression of a fast track or the crashing, what technique particularly we're gonna use it. So as you can see, what we do have over here, we do have a work performance data here also, because we want to know how the schedule work performance is going on. We need that data, raw data, so that an output we can make a report. We can take that information and create the work performance information / reports. Schedule forecast. The reason is this because if we are seeing from time to time what's going on with our schedule, if we are slow, we're gonna do fast tracking or a schedule compression of a crashing. We can forecast it, that if we're gonna meet it on time or not. If we are, then it's great. If you're not, like, we really have to take one technique out of it. You really know a lot, everything out of it. The terms you need to know is just the iteration burn down chart, which you really don't know, which you really don't need to know for the exam, but just a kind of a glance if I have to give you. It is a chart which, when you're gonna open the PMIS software, you're gonna open it, and to a project manager, a burn down chart like this or this shows onto his or her screen. The reason it shows, because remember, we do have so many activities and we do have a time duration for that, and so this burn down chart tells if any activity passed the due time or not. If it does, you have to go into that activity and see why this has not been closed or why this not has been done. So that's it. This is the rule of burn down chart. The other thing you need to know about the resource optimization, we do have a two type of resource optimization. Basically, it's nothing, it's resource leveling and smoothing. What's the difference between resource leveling and resource smoothing? In easy words, I'm gonna tell you. Just 1 second. So resource leveling, it's coming from the word what it is actually. So it's saying whether it's Jan, Feb, or March, April, every single month, we want our resource to be at a certain level. If you're using 10 developers a month, we want to use the 10 developers a month on the next one too, and we're going to use the 10 here and 10 every month. And if they're working for 8 hours per day, we want them to work 8 hours per day for Jan, Feb, March, and April, and for so on, whatever the months we are using it for our project. So same number of team members with the same number of hours we are giving to them. This is what the resource leveling is called. What is resource smoothing? It's like more smoothing. It's saying the same thing, same number of developers or team members with the same number of hours given to them, but there is an exception in smoothing. The exception is this critical path. It's saying that we're gonna give only 8 hours per day. We're gonna give only 10 developers or team members per month. But if it's a critical path and it's an emergency, we're gonna smooth that out. We can give 10 hours per day. Although no company wants to give overtime, so they might gonna increase the developer. Instead of 10, they're gonna put 11, just because they have to complete the critical path. You got it. And this is exactly, and we are done with this chapter. Now I'm gonna see you in your next chapter.